So, in the penultimate part of the question, it's asking you to draw hypochloric acid. Now, it tells you in the question that the formula of hypochloric acid is HOCl. So therefore, I've put oxygen as the central atom. I've drawn circles to represent my hydrogen's electron, crosses to represent the oxygen's electrons, and triangles to represent the chlorine's electrons. And so the oxygen and the chlorine each have 8 electrons in their outer shell, hydrogen has 2. I could also equally draw it. Actually, let's stick to the triangle scheme. As that, with a dative covalent bond between the chlorine and the oxygen. I didn't choose that because in that case chlorine would be the central atom, and that's not the way the formula is drawn in the question, but the mark scheme gave you that as a possible option. In the next part of the question, it's asking you an unfamiliar reaction. Now you guys would have probably thought, I've not seen this reaction before, therefore the question's unfair, Mr. Campbell's not taught me properly. But it's asking you to apply what you've been given in the question to see what might theoretically happen. It's called an AO2 question. So, you've got some hypochloric acid, and you've got some HCl. So, you're going to form some water. You've got an HO here and an H here, so that's going to form water. And then your leftover product is chlorine gas. The problem with that reaction is chlorine gas is toxic, so you can't have a mixture of hydrochloric acid and hyperchloric acid in your reaction. And the next question is asking you for oxidation states. We did this in one of the intervention sessions, where we looked at the charge of each of the species. So in chlorine, that's a covalent substance, therefore it has a charge of 0. Here it's an ionic substance, it's next to sodium, which has a +1 charge. Okay, overall it's 0, so it has to be -1 to cancel out that +1 charge. Again here, sodium's +1. But this time the oxygen's -2, which gives me -1. Overall is 0, so the chlorine has to be +1 to make 0 overall. The bit that we've not done yet, that I didn't include in the number of marks, was what it's called when chlorine goes to both a negative oxidation number and a positive oxidation number. That's called a disproportionation reaction. But I would have expected you to recognise that that's going to need the chlorine to either lose electrons or gain electrons, and that's going to be more likely by either increasing the temperature or increasing the concentration of sodium hydroxide. And in the final question, the way I started off the reaction is to look at the fact that I'm making NaClO3, okay, and I'm making some water. Okay, I know that because I've got the idea that I'm making some water here, so it makes sense that I'm going to make water again. If I'm making 3 lots of oxygen from the perchlorate, it makes sense that I'm going to make 3 lots of oxygen in the water. Why does that make sense? Because oxygen has the formula of O2. So if it splits up, if I've got 3 lots on one side, it makes sense that I'm going to have 3 lots on the other. Or 1 lot on one side and 1 lot on the other. And then I'm just going 3 lots. O2.